Welcome to another video on rigging, and this time this video is on steel wire rope and steel wire rope slings. So they say they are basically correlated to each other, and both of them are helping in load lifting in rigging. As I have told you already, that load lifting and transporting it to this desirable places, and that has to be done in a safe manner. The entire activity is encompassed in rigging. Steel wire rope plays a vital role in load lifting, and it finds application in different types of industries for different types of activities. As it is used in control cables, general engineering work, mining work, slings, winches, vice, cranes, drilling machines, non-spin applications, general purpose bell wire applications. It is also used for lashing, blasting barricades, and stainless steel and the copper fittings, where rust prevention is essential. Steel wire rope is very important part of the rigging activity, as I told you. It is very important to understand the construction of steel wire rope. The construction of the steel wire rope is very easy to understand, but at the same time, I will also say that steel wire rope is a very complex piece of load lifting machinery. It has a number of parameters that needs knowing if you are dealing with the rigging as a subject. This entire thing is a wire rope, and that wire rope consists of different strands. And the strand in the middle of in the center of the wire rope is called core. The strand consists of individual wires, as you can see in the picture here, that there is a wire in the center of the strand, and all other wires are woven in a helical manner. They are laid in a helical manner around the central wire, and this forms the strands. Many such strands are wrapped around the core, you know, in a helical pattern, and this complete structure is called a wire rope, and this plays the vital role in load lifting. So wherever load lifting is there, it is quite probable in the case of the heavy load lifting that it will be a wire rope. Here a few more details has been discussed, as in the case of the fiber core wire rope. Uh, the fiber core wire rope has a fiber core. Basically, in the central strand is a fiber core made of synthetic fiber or of natural fiber. In either cases, it is very flexible as compared to steel wire strand, because that provides a strength. A steel wire strand would definitely uh, provides a strength if it is in the center of the steel wire rope, but fiber core provides flexibility to the steel wire rope, and that is why it is more useful, where the flexibility of the wire rope is more important, and where strength is important, there we use steel core steel wire ropes. You know, then both the types of the configurations are important from different point of view of applications. Now, if you cut a wire rope, uh, this cross section of the wire rope will show you certain uh, beautiful pattern of the wires in a pattern. They are uh, laid. So basically, they are of different types. They are named as single layer, where a single layer of the wires are arranged around a central wire. So central wire is one, and you can see six wires are uh, covering this wire, center wire, and that is forming a single layer. So that is why it is known as single layer pattern of the steel wire rope. And then you have filler wire pattern, which has two layers of the same diameter of the wire. But as the filler wire, that is the uh, gap uh, between the four, these four wires. There is a gap, and that gap is filled with a smaller diameter of the wire, and that is why it is called filler wire pattern of the wire rope. In Sile pattern of the wire rope, basically there are two layers, but they are of different diameters. The central wire and the most outer layer are of the same diameter, but in between layer is of a smaller diameter. So this is called Sile pattern. Then you have Warrington pattern of the wire rope, where you have a central wire and around which the first layer is of the same diameter, but the second layer is of mixed diameter of a small and same diameter wire rope. So basically, Warrington also has got three layers and a filler wire, relay pattern. All these are three layers have been shown, but it could be of more layers also. And then you have a combined, type of the steel wire rope, whereby you have mixed, arrangement of the wire rope, so that you have already studied the filler wire, relay pattern, or the Warrington pattern. All these patterns are mixed, then it is called combined pattern. So, one question might be arising in your mind, that why at all this type of different patterns are existing, and what is the advantage of having these patterns? So, your question is quite valid, and let me explain it. These different types of configurations lead to different types of mechanical, properties in different types of wire ropes. Like some of the mechanical properties could be, you know resistance, abrasive resistance, and then you have a resistance to corrosion, uh, fatigue resistance, rotational resistance. And these are the different types of resistances that are very much required in the case of steel wire ropes, because they provide, mechanical uh, advantage, different types of mechanical advantage. So, uh, different types of laying is also, you know, practiced in the case of wire rope laying. So, they could be of different types of laying that we have not discussed in this case. We also have, galvanized steel wire rope, as it has been shown here. The galvanized wire rope has the advantage of, being rust resistant, corrosion resistant, because corrosion is something that, makes the wire rope weak over the time, and this happens because of their exposure to the moisture and rainy water environment. So, in order to make them rust resistant or corrosion resistant, these are galvanized. You also have different configurations like 6 into 36 or 14 into 14 is to 7 plus 7 is to 7 is to 1. Fiber core, galvanized and ungalvanized, 1770 and 1960 megapascal, mining, slings, general engineering, winches, hoist, cranes, etc. In different uses, this type of wire rope is used. So you can go through different types of, a lot many different types of wire rope configurations for different types of, applications are there. And this is, for different applications, different mechanical properties are required, and that is why they are, sold in different types of configurations and different types of lengths. Here we are going to discuss about the end fitting of the wire rope, and in the first picture here, this is called clevis fitting, and this clevis fitting is required in special kinds of the lifting of loads. And then we have wire rope with bulldog grips or clamps, U clamps sometimes also it is called, and this is to secure the two ends of the two layers of the wire rope one on the other, and with the thimble. This is a thimble inside, and that helps to lift the load without damaging the wire rope. And this is called a spliced eye. Basically, one end is woven into the live end of the wire rope. The end that is shorter end here is called dead end, and the end that is running throughout the length is called live end. So live end and dead end are woven together in the helical pattern that it has by a specialized or skilled person, and this is called a spliced eye. Then you have wedge socket, which is of a wedge type of structure, and this type of sling is also used for load lifting. And then in the stop, this basically stops the uh, you know mm, uh, wire rope should not get loosened at the end, and its strands should not open up in a you know that if it is left loose, then it will definitely scatter and will add to inconvenience when it is being used. So Eureka wire lock is this. It is a kind of the socket basically in which this wire rope is getting a wavy pattern, and that stops its easier, lapses. Then you have a thimble again and a spliced eye. Here it was a soft eye. This is a thimble eye, and this is hard eye. You can say that this does not flex. This is not flexible as this one is. So this thimble protects the surface of the wire rope when the load is being lifted. Then you have again have a socket for the elevators and wire rope clamp. So these are the different types of the end fittings that we use in the case of steel wire rope, and that helps us to protect the end of the wire rope where the load is secured and lifted. Sling is used in different configurations to lift the load. Basic three types are vertical hitch, choker hitch, and basket hitch. So, in the case of the vertical hitch, sling is used vertically. One end is secured in the hook, and the other end is secured with the load, and the load is lifted. In the case of the choker hitch, the single sling is used, and an eye is formed with the help of basically this configuration is called choker. On the eye, through one eye, the other eye is inserted and hanged into the hook, and this configuration is called choker hitch. In this case, the sling strength is compromised, and this depends on the choker angle. This is called angle of the choke, and the strength of the sling depends on the angle of the choke. Higher the this angle, higher will be the sling capacity. Lesser the angle, lesser will be the sling capacity. This is called basket hitch, and you have two configurations. Here, this basket hitch is, angled basket hitch. If this angle is 90-degree, the sling will have its maximum capacity in the form of the basket hitch. and double the capacity of the sling, you can lift the load. Uh, that means if this sling is of 5 ton capacity, you can lift 10 ton of the load with the help of this sling, provided it is used in vertical configuration, vertical basket hitch. That is called vertical basket hitch. If these two ends are at 90-degree straight upward, then you can lift double of the capacity of its uh, uh, capacity of this sling. But here, as because this is angled or slant, you cannot use 100% capacity of this sling. And this capacity reduction depends on the angle with which it is slanted. So that is a different discussion we will have in some other video. Uh, that's it. And here I have tried to show you different types of configurations again in the case of sling. This is endless sling, and this is uh, an eye sling. This angle must be at least 15-degree. This is 15-degree, and this is 30-degree. So eye splice is done at this place, and this is eye to eye sling, and needless to say, this is endless sling. And here, the choker configuration, as I explained you, has been used, and fiber rope thimble has been used at this end, which is secured with the hook, and this is called angle of choke, as I told you earlier. Multiple leg bridle sling in this configuration has been shown, and this is a master link in which these two slings are secured, and on the other end we have a hook, and that is secured with the load. So this angle is called horizontal angle, and sling angle also sometimes it is termed as. So this sling angle decides the capacity of this sling, how much is the reduction in the capacity of the sling is depending on this angle. Let me explain you in short that how this capacity reduction takes place. Just you have to take the sine theta of this angle. So suppose it is 45-degree, the value of the sine 45-degree happens to be 1 by root 2. And if you take the decimal value of 1 by root 2, it is 0.707. And if you turn it again to percentage, 0.707 is equal to 70% approximately. So you can use up to 70% of the sling capacity. That means if it is of 10 ton, then only 7 ton is its capacity at 45-degree of the angle. So that has to be understood very clearly when you are using the sling. So whatever kind of the sling it is, chain sling or uh, steel wire rope sling or fiber natural fiber rope sling or whatever it is, the capacity reduction takes place if it is used slantly. So that is it, and that is an important discussion. Thank you. Uh, here, uh, different types of the slings in different configurations have been shown. So as you can see here, these Flemish shocked eyes are there. This is thimbled eye, and this is again socketed sling. Here also socketed but thimbled also. This is again a soft eye, but a spliced one. A choker configuration. Four-legged slings, two-legged slings, two-legged soft eye slings, uh, two-legged thimbled eye slings here. Okay, four-legged soft eye slings and basket configuration of the sling. Here, the D cycles have been shown, and bow cycle has also been shown here. So these are, used to secure the load properly uh, with the hook. So, two-leg bridle sling, three-legged bridle sling, or four-legged bridle sling. These are the different configurations of the sling for load lifting. You have different types of the load lifting slings, basically eye to thimble, eye to hook, eye to crescent thimble, eye to slip through thimble, and thimble eye, thimble and hook eye, thimble and crescent thimble. Crescent thimble basically has a small piece of the thimble that slips through this eye, and slip through thimble. When it is put on the load, it slips on this eye, and that is why it is called slip through thimble. Crescent eye also slips on this eye, but it is a small piece of the metal that protects the sling at the loading point. So you have crescent thimble and hook, you have crescent thimble and crescent thimble on both the sides, slip through thimble and hook, and slip through thimble on both the sides. You have eye and eye. This is basically a choker configuration, eye and thimble. This one is having soft eye, and this is thimbled eye in the choker configuration. So yet another important part of the sling is its capacity in tons or kgs. So how to if you don't know the capacity of the sling, but you have the sling and you want to know what is the capacity of the sling. So you can approximately calculate this sling capacity by measuring its diameter. Take a slide calipers to measure its diameter in mm, and square it and multiply with 8. So the figure that you get by squaring the diameter in mm and multiplying by 8 is its capacity in kgs. And if you convert it into tons, you have to divide it by 1000, so that will give you the tonnage capacity of the sling. So here we have taken an example. The diameter of the sling is 20 mm, and if you square 20, then you get 400. 400 multiplied by 8 becomes 3200 kg as the capacity of the sling, and if you convert it into tonnage, then it is 3.2 ton. So that is how we convert. We know the capacity of a sling that is unknown. SWL is the safe working load for a sling, and that must be known. And we should never exceed the capacity of the safe working load of the sling in any case, because that could lead to, failure hazard. And if it fails, it can make a fatal accident sometimes. That is why SWL is an important figure that we have to know and we have to regard. MBL is minimum breaking load. Basically, minimum breaking load is a load uh, that your sling can bear before it fails. So any further addition to that load will break the sling. So that is the maximum load you can put on the sling, which it can bear without failing. But we have to rely on safe working load rather than minimum breaking length. Minimum breaking length is a figure that is important for the manufacturers, because they have to test the sling on this minimum breaking length to know its mechanical strength, and that is of no importance for the users. They have to rely on safe working load. Say they should make it a rule that they are not going to cross the safe working load in any case, and that has to be regarded as much as possible. SWL and MBL have got some relationship. Like if your SWL is 10 ton for the sling, your MBL is 50 ton, uh, considering that 5 is the safety factor. So if you multiply the SWL with the safety factor, you will get the MBL, that is minimum breaking length. Here SWL of some of the different diameters of the sling has been shown, and this table is very important for the people who are constantly working in the rigging area and using different sizes of the sling. So they must have this type of table and this is provided by the manufacturer from whom they are buying their slings. Right? Thank you very much for patiently listening this lecture and upgrading your knowledge. Uh, you must be having some query. You can write in the comment of this video, and you can ask your questions. If you are liking this video and wanting to interact with me, then also you can write in the comment box and tell me whatever you want to say. So till then, till next video, have a nice time. Thank you very much. Stay tuned.